All right. So I was asked to explain asynchronous programming with RxJS. So here is my attempt at doing so. Now, with most programming languages, we are coding in a synchronous manner. Means all the code that you write gets executed line by line. Um, there's no real concern for order of operations. So when you call a function, you expect the entire function to run its course line by line, and there's no going backwards up to do something else. So with asynchronous programming, you are able to register a function or a callback to be executed at a later time. So let's do a simple example where we have to call a couple of back-end services and get some data before we can do some processing on the front end on our application. So I'm going to do this using an analogy. Let's imagine our app as this home. And we're going to have events that occur when the user performs a certain action, like clicking a button. So when the user clicks a button, that event gets input into our application. And this application then probably runs a function which is then converted to a different kind of event, a fetch event to the store, to our backend services. So this event then goes out to the backend, and when that backend service is ready to respond, it will then send a response back to your app. And that is the happy path. When nothing goes wrong, your user clicks a button, that event goes out. So it goes out from your application. It turns into a fetch event, and the fetch event comes back as a response. Okay? So that is the happy path. There might be situations where you end up you make a click event. Okay, so this has no chance of failing. You might click the wrong place, but eventually the user will end up clicking the right place to place a call to the backend. So when you call the backend, there is an opportunity for error. You might have connection issues. You might have login issues. So this event will get struck. So this little guy that came out to try to get something, he got into a big accident, and now he's not able to fetch the response. Can I select both of these? And yeah, these go off into the wilderness somewhere. And now your event is lost. There are what's called error events that get fired back. So not entirely all lost. It just gets shoved right back to the app without having actually hit the store. So there's a possibility where you have a timeout. So you make a call, the call just takes way too long, and it just times out. So when that timeout happens, it comes back and says, hey, I didn't get anything. So that's one of our error scenarios. So same thing could happen. It could get all the way to the store and then it says, oh, where's the key? Where's the keys? I forgot the keys. Oh, okay, I can't get in. So it comes back and says, whoops, I forgot the keys. I couldn't get the eggs. So that's another sort of error that could happen. Or something else that could happen is they got the keys, they get to the store, and then something in the store is wrong. Maybe they're out of eggs, or um, the eggs are all broken. There's some sort of exception that happens in that store that says, I can't provide any data to you. I can't provide any eggs to you right now. So that could happen, and it could respond with what's called like a 500. So some sort of internal server error. All right. So try to bring, we'll leave the other guy out. All right, let's try looking at some code. So hopefully you can see my screen now. Check. Yeah, so we're looking at the code. All right, so we have a couple of stores here. So this is where we're injecting the stores, and these will act as our back-end services where we're going to make calls to. Right now, they are just giving us some mock data. We have this local state here. If you want to think of it, this is where we store our ingredients. Now, it could be something else. It doesn't have to be a fridge. It could be anything to store your local data. It could be a book. It could be a box, a toolbox, right? So it can be anything that you want to store some sort of data. And to explain this part, this is Angular's lifecycle event, which happens when we load this component. So on init, we want to make a call to get some ingredients. So when the call happens, this could be a click event. We could wait for the user to click something. So on init is just another sort of event that we can listen to say we want to do something during that event. So we want to call get ingredients, and the get ingredients calls this fork join. Fork join, if you want to think of it as sending two carriers. Think of it as, yeah, two carriers. Like one is going to the egg store, and one is going to the mayo store, and you send them both out at the same time. Okay. You can say, hey, Jimmy, go get the eggs, and hey, Timmy, go get the mayo. So you send them both out, and they're running off, and we'll just have to wait until they come back to make the egg salad. So in the subscribe, this is where we expect some sort of event to come back. So in the happy path, Timmy and Jimmy both come back and they bring the groceries. So this is the grocery event. When this happens, now we have the ingredients required to make the egg salad, right? We have the eggs and the mayo. what some people like to do, and this is probably before they understand how asynchronous programming works, is they would subscribe and then immediately try to make the egg salad. And as you can see, there's nothing that we can pass it in this instance unless we want to pass it items. Oh, sorry. So this dot items. So this dot items is whatever is in our fridge, which may contain the mayo and the egg. But if you remember, we don't actually have those yet. Eggs is empty and the mayo is empty. They're not back yet. So there's no guarantees that this code will make a successful egg salad. You must wait for the subscribe to complete, this callback to complete, before you're sure that there is sufficient ingredients to make your egg salad. Now, if I were to run this code, let me just save. And when a console logs number 1, you're going to see that this inner console log is going to console log empty, the empty strings, because this has not been populated yet. When it console logs 2 and 3, and then calls make egg salad, again, make egg salad console logs a second time with the proper ingredients. So let's head over to our browser. Okay. I'm going to refresh. So, like I said, number 1 runs, and then it tries to console log what's in the make egg salad function, but there's no ingredients. So there's the empty console log, and then 2 and 3 in the subscribe happen. So number 2 is we got the ingredients, and number 3 is now we can start actually making the egg salad. And this last one here is the make egg salad function again. As you can see, the line number is the same. So line 49 is where we have the console log in the make egg salad function. So let's check the code again. So in the code, we say, if you try to make the egg salad, number 1, and then try to use what's in our fridge, there's nothing in our fridge. So you're not going to make an egg salad. And then number 2 and 3 happen. And it's very strange, right? We have number 1 down here. Number 2 and 3 are up here, right? So what you would expect to see is it would console log 2 first and console log 3, and then console log this. But when we see it in the actual application, you see that this, number 1, is console logged first because of that asynchronous programming, right? It takes some time to go to the server. So your HTML, your local browser, the browser on your machine needs to go to the server to get some data. So this egg store is the server, and the code that is running, all of this code is local to your machine. So when it calls the egg store, it actually has to make that trip from your computer to the server and back before it can actually do anything. So that's asynchronous, right? So we're registering this event to happen after these responses come back, right?